Welcome to The Explainer. Today we're diving headfirst into one of the most profound puzzles of our entire existence. We're going to unpack the mathematical inevitability of alien life, the surprisingly grounded mechanics of interstellar travel, and the absolutely terrifying reasons why our universe remains so perfectly quiet.
Here's our roadmap for today. We'll start with 1. The cosmic timeline, then look at 2. Crossing the void, and tackle 3. The Fermi Paradox. After that, we'll hit 4. The Great Filter, explore 5. Terrifying alien scenarios, and wrap up with 6. The ultimate silence. Let's get right into it.
Section 1. The cosmic timeline. To really grasp this, we need to completely zoom out and look at the sheer mind-boggling scale of cosmic time. The universe is 13.8 billion years old. And hey, that's not just a rough guess. That's a hard number, backed by decades of intense, precise measurements. It is the literal foundation for this entire mystery.
When you lay it out like this, you can really see the massive head start the rest of the universe had on us. I mean, billions of years of planetary evolution were happening before Earth was even a theoretical cloud of dust. Think about it. If another civilization got started just 1% earlier in cosmic time, they'd have a 130 million year head start on us. That is absolutely huge. Section 2. Crossing the void. Now, this part is fascinating because it completely shatters the myth that interstellar travel is impossible. And we're going to prove it using only known, rock-solid physics.
The big takeaway here: crossing the massive voids between stars doesn't actually require sci-fi magic or faster-than-light warp drives. It just takes engineering ambition and a whole lot of patience. Stuff like nuclear pulse propulsion or fusion drives, technologies that don't break a single law of physics, could literally get a spacecraft to our nearest stellar neighbor, Proxima Centauri, within a single human lifetime.
And here's the kicker. You don't even need fragile biology to make the trip. By stacking these 4 very real strategies, an ancient civilization could totally bypass the limits of human lifespans. They send robotic scouts first, then self-replicating machines, then immortal AI, and finally, the massive generation ships. Using just these slow, sublight methods, a single civilization could spread across the entire Milky Way in 10 to 100 million years, which, in cosmic terms, that's just a blink of an eye.
Section 3. The Fermi Paradox. So, if traveling between stars is mechanically doable, and the universe has had billions of years to cook up civilizations, we crash right into a massive, glaring contradiction.
This is the Fermi Paradox. Dreamed up by physicist Enrico Fermi over a casual lunch in 1950, it points out a huge problem. A single expanding civilization should have absolutely filled the galaxy with probes and signals by now. The math basically screams that they should be everywhere, and yet, the sky remains completely, hauntingly quiet.
There are tens of billions of potentially habitable rocky worlds sitting in the Milky Way alone, and many of them are billions of years older than Earth. So it all boils down to the simple, four-word question that absolutely demands an answer. Where is everybody? Section 4. The Great Filter. Let's look at one of the most famous theoretical answers to this paradox, which really deepens our cosmic mystery.
The Great Filter suggests that somewhere on that long road from dead chemistry to a sprawling galactic empire, there's a barrier, a step that is almost impossibly hard to get past, basically a cosmic bottleneck.
So why does this matter to us? Well, because we have absolutely no idea where that filter is. If it's behind us, like, say, the incredibly complex leap from single-celled life to complex animals, then wow, we are incredibly rare cosmic lottery winners. But if the filter is still ahead of us, that implies civilizations inevitably destroy themselves, maybe through nuclear war or climate collapse, and we're just sitting here, waiting for our turn. Section 5. Terrifying alien scenarios. All right, I'm going to pivot to something a bit colder here. Because what if civilizations actually do survive that filter? The theoretical reasons they haven't said hello are grounded in some absolute terrifying logic. Take the dark forest theory. Imagine a pitch-black forest full of armed hunters. Game theory tells us that broadcasting your location is incredibly risky, especially since an alien species technology can grow exponentially. So the safest move? Stay totally silent. And if you stumble upon a new civilization, you immediately launch silent light-speed trajectories to wipe them out. No warnings, just cold, preemptive survival.
Or how about this scenario? We might just be a sociological experiment, or maybe a cosmic nature preserve. The silence isn't an accident. It's entirely by design.
Just like our anthropologists don't contaminate uncontacted tribes, we could literally be lab rats. And you know how experiments go. The second we stop generating useful data, our little petri dish could be quietly thrown out. What if the silence is actually being enforced by ancient automated tech? An empire from 1 billion years ago could have easily left behind these unthinking security grids that enforce hard limits on technological progress. If we cross a certain threshold in superintelligence or energy use, bam, we trip an invisible wire. To us, it'd look like an inexplicable, tragic catastrophe. But to the system, it's just routine protocol enforcement.
Honestly, the evolutionary gap could be so massive that our existence doesn't even register as meaningful to them. Advanced species might just ascend to post-biological states and leave physical space entirely. Or a superintelligence might do the math and conclude that conscious suffering is just an error that needs to be cleanly debugged from the cosmos. Or, perhaps even worse, they aren't malicious at all. They just see our planet the way we see mold on an old motherboard, totally irrelevant until they need to wipe it clean and use our sun as a computational node. That sheer indifference, it's chilling.
Section 6. The ultimate silence. Now, despite all these mind-bending and frankly scary scenarios, we've got to ground ourselves in what we actually know today as empirical fact.
And the fact is, we've barely even started looking. Our SETI searches, our radio telescopes scanning the skies, have sampled the equivalent of maybe a hot tub's worth of water compared to all of Earth's oceans. So the fact that we haven't found anything yet, statistically, it's pretty meaningless right now. On top of that, we've only been broadcasting our own signals for about 120 years. That creates a microscopic bubble in a galaxy that is 100,000 light-years across. We are virtually invisible to a universe that operates on timelines stretching into the billions of years.
But as we gaze out into the dark, we have to hold the tension between these two massive truths: a universe that is mathematically perfectly capable of harboring ancient life, and the undeniable reality that we haven't seen a single, solitary trace of it. The silence itself is a data point. It's telling us something profoundly important about the nature of existence.
So, if the universe really is a dark forest, is our decision to scream our existence into the void our greatest achievement or our final mistake? Are we reaching out to a bustling community, or are we just happily ringing the dinner bell in a forest full of predators? I'll leave you to chew on that next time you look up at the night sky. Thanks for joining me for this explainer, and keep questioning the silence.